Okay, now in the last session, pretty much we were seeing the previous module was based on SCM. So we saw how a user tries to do changes and how he stores the changes, right? And that is more about on the SCM side. Now, what will happen after that? So pretty much now, once the coding has been done, we have to give it to the QA. So when you give it to the QA, what exactly does the QA pick? Now, when the development happens, they will be writing code in a specific programming language like C, C++, or Java. And from that, you are going to create a product, and that product is what the QA would be taking, and further the customers would be taking. So in that ways, if you see, when you say a product as such, what exactly it is? So it could be a combination of several executables or something what we call it as deliverables, and using that you will be able to run an application or do some activities as a product. So in that case, how do you convert these source code, that is the programs that is being written by the developers, into a product is what we call it as a build management. So basically, build management is nothing but a process where we convert the raw code which is being written by the developers in some kind of programming language and converting them into a machine understandable format. And later on, you assemble all the files which you have converted into the machine understandable format, and from that you create a software together, and that complete process is what we call it as the build management or building a product. So generally you would have hearing, or you would have been hearing this word a lot, saying that building a product or build a product or build. So what exactly do we mean by that? So a build represents you are creating a product from a set of files. What kind of files? Some program files. So these files are called as source code or raw source code, because that is the one that contains all the program which will drive on how the project should be running. So what happens internally is a build is basically a two-step process. So the first step that we do is compilation, and then we do something called as assembly. So what exactly is a compilation? Now let's take an example of a Java build system or a Java based project. So now ideally, when the developers are creating files, they will be creating some Java files or files with the extension called Java, where these are the raw source code. When I say raw source code, the file will be written with some contents specific to a program called Java. Now, these files cannot be directly used, wherein first we have to convert all the individual files that you have into something called as object files, where that files are the ones which the machine will understand that it has to run something. So in that way, the very first step, that is compilation, is all about converting these raw source code into object files. Okay, so that is what we call it as. So now for every source code that you have, you will be getting equivalent object files. Let it be C or let it be C++ or Java. For every source code or every file, when you do the compilation of it, you will be getting an object file. Okay, and in that case, since as of now many users work on Java based system, so we'll be going through the Java build system and how you will do this compilation and create a product. So in that ways, now when you do this step called compilation for this Java files, for each of the file you will be getting an object file, which is what will be in the extension called .class. So now this is the file that we can run and that will be used by the machine, through which it will try to understand what you have mentioned in it and it will run it. So converting these Java files into class files is what we call it as compilation. And now, once you have converted all those things, now you cannot use all these files directly, because when you say a product will be having many functionalities. So that is when what we do is we will combine, or we will assemble these class files or the object files, and out of that we will create a deliverable or something called as artifacts. So that will be the one which will be acting as a product, or that will be acting as a file which we will be using, and when you execute it internally, it will call these files which is inside that, and you will get the functionality of your product. So in that way, we assemble all these files, that is the class files in the terms of Java, and from this you create a deliverable. Okay, so when I say a deliverable, that could be a product where it could be a single deliverable or multiple deliverable, because now let's say you have hundreds of files where you will be segregating the group of files based on a functionality, and out of that you will create one deliverable. And in like this, for the remaining files you will be creating separate deliverables, and everything together is what we call it as one product, where each deliverable can be having a specific functionality, or depending on the size of the product and functionality of the product, you can create one single deliverable which will have all the files. So that is what the build system will be all about. How is that you're going to convert this? How is that you're going to deliver the deliverable, and how is that you're going to give it to the customer? So in that way, on a Java build system, the type of output that we get, which is called as deliverable, are jar files or var files or EAR files. So finally, when you are building a Java based project, the output of the file that you will be giving it to the QA or the customer will be any one among them, where these are nothing but the deliverables which will be containing certain class files together in it, where a jar file is a simple archive file. Jar stands for Java archive. Just like how you have zip or tar file, for Java files, if you want to archive it, you will be creating a jar. So jar is nothing but basically an archive in which you will be having specific class files which defines a functionality. Whereas this jar file can be used to provide a single functionality. The same thing, if you are using your files to run a web-based application, then you will be creating an extension called var, where var will once again contain these class files, but in addition to this, it can also contain a jar file inside it. So depending on what are the functionalities and how you are creating, a var file can directly contain many jars, or it can contain class files, and along with it, it will be having certain files which will specify your web application. Okay, so any kind of web application that you are trying to create as a product will always end with the extension called .var. And in case if you want to provide a license for that web application as an enterprise archive, then it is called as EAR, where var stands for web archive and EAR stands for enterprise archive. So both are the same. The only difference is in this file, it will also have all the combination of class files or certain jars, and in addition to that, you will be having certain configuration files for defining your web application, and along with it, you will have a license, that is an enterprise license. So that is what will be the output of a Java build system. Okay, and these steps where you first convert all the Java files to the respective class file, and then you create a deliverable, is what we call it as compilation and assembly. So assembly is all about creating this jar or var or EAR. Okay, so that's what we call it as a build management or build step or process. So now, if you look at this, we always need to do a automation in terms of how do you do this build. Because what happens is, now in a product, it will not just be one file that you have. You will be having thousands of Java files. So how do you try to do all these steps together in such a way that you will reduce the time in creating the deliverables, or the build time, that is the time that you use to convert all the files in terms of compilation, and how much of time that you take for the assembly. So all those things has to be specified, and we need to automate to make sure that everything runs smoothly and as soon as possible. So in that case, build automation is all about writing some kind of script or automating all the steps that will be part of the build management. Okay, so if you look a closer step at the processes what you will be having at the build, it is not just simple where you will just do a build and then create a deliverable. As we are trying to simplify the process to make sure the software development is quicker and it is easier, and we also capture all the errors, what we do is we can do many other things along with the compilation as part of the build automation. That is when you say build automation, we majorly focus on compiling the source code, that is converting the Java files into class files, and then packaging the binaries. So when I say packaging, this is what we call it as packages. So a deliverable is a common term, but sometimes we also call these as packages. Okay, so creating these packages is also will be part of the build automation, and we are not going to stop only at that. We can still increase or improve our process of build by adding the automated test also along with it. So now why is that we have to make it separate? Instead of it, as soon as you do the compilation and create your packages, you can go ahead and do the test on that files that we have created here, right? So that it will be immediately verified. So that is how we make sure that the automation is as much as better and it does all the tasks. And if needed, we can also take these files, that is the packages of the deliverable, and do a deployment to the production system. So when I say deployment, if you have a customer who wants to access the files as soon as possible, then you can put into the production system so that they can access it. So that step is what we call it as deploying. And in addition to this, we can also do documentation automatically in terms of whatever is happening in it. So that is the major advantage on why we will be doing a build automation, wherein you will have all these steps. Okay, and majorly the purpose and the advantages of doing the automation in build is, first what we will do is we will make sure that whatever redundant tasks that we have will be eliminated. Redundant task means, now if you do a build once, you have to compile all the files and create a deliverable. Now after some time, if you want to do a build once again for another set of changes, you have to do the same thing again and again. So these kind of repetitive tasks can be eliminated by writing a script or by automating the steps. And what we can do is we can accelerate the compilation and the linking processes, because now we know that how it will happen, what and all will happen. If there is anything that we can do in parallel, we can do it, and those kind of steps will help us to ensure that the complete build process will be done quickly. And what will happen because of all these things, in case if there are any issues that could happen because of manual intervention, because now when you have thousands of files like this wherein you have to do so many tasks in the build, if as a user manually, if you're trying to execute one by one, if you do a mistake somewhere where instead of doing this first you did something else first and nothing is working, or you forgot a step, so in that cases, by automating all the steps, we don't have to keep remembering everything, because the automation will take care where we will tell on what and all things should be happening. And in that way, it will minimize the bad builds or the builds that will be breaking or it will not happen. Okay, and not only that, majorly now whatever steps that we are doing, we can easily track them, and we can keep a history of whatever is happening. Now if you keep doing a build like this, which will take, let's say, 1 hour, now on a daily basis, if you're doing 2 to 3 builds like this, how can you keep a history of what you did 2 days back or 3 days back? What and all files did you pick? What is the deliverable did you create? Did everything work, or is there any problem? How did you fix it? So all those kind of things will not be possible for us to manually store and maintain. Whereas if you automate the build step, it will be easy for us to have a history of what command that we run, and in that what and all files did it compile or it take care of the build is what we will do. So majorly the build automation is going to help us in saving the time and money in the reasons of all these things, because you will be trying to automate the steps quicker. So it is not only that we give it to the QA, but as soon as a developer completes his coding, in order to do the verification, even he has to do a build of his specific files, so that he will quickly do the changes of his file where he has modified, and corresponding to that, whatever deliverable that will be getting impacted, he will have to create it and test it. So that's how build is an important step which will be used by the developers, and through that we will be creating a deliverable, and this is what we will be giving it to the QA. Okay, so that's the important step, where after the development you will go through the process called build, and the output whatever that you get is what you will be giving it to the QA, and once they verify, the same thing is what will be given to the customers. Getting it on what is a build, and on an overview what you will be doing on a Java based build system.
Yes, Adam.
It's clear.
We are getting Adam.
So now when I say you are going to do some build automation, whatever steps that I was talking about, that is compiling, creating a package. So when I say binary, binary is nothing but a file which is what we are creating as a deliverable, right? Because a binary file is nothing but a file which is understandable only by the operating system. So other than that, it will be a text file that we can read. But if a file is an executable that we are supposed to run and get some functionality, then those files are called as binaries. So usually whatever that we give it to a customer is a binary file which we run and get some output out of it, which we can use it as a product, right? So in that way, we call it as packaging a binary. So all these terms, that is artifact, deliverable, package, will all be the same, where what is the type of file that you create? It will be basically a binary file. So now, going back, so when you want to automate these steps, wherein a build automation can do various things like compiling, creating packages, unit test, and also deployment and creating documentation. All these things can be done, right? So how is that you're going to do the build automation? Now, if you're writing some small script, or again, you can write a program itself for that, but it will not be an easy task to do, because there will be several things that you have to keep adding, keep modifying, and we need someone to separately maintain, and only those who is aware of all these things can go ahead and do. So that's when it will be tough to maintain if we keep writing a script. So that is when, for automating the build task, there are tools called as build tools. So build tools are specifically used to ensure that the automation of the build related tasks that will happen. Okay, so in that way, for Java based products or Java-based system, earlier they were using an open source tool called as Ant. But now, because of certain drawbacks in it, or because of the things that we want to be more simpler when we are focusing to DevOps, and we want things to happen very quickly and the maintenance effort should be less. So in that way, they started to think about having a better tool. So that is when the Apache came up with a better tool called Maven, which is having all the features of what we will be having on the Ant, but in addition to that, it also has certain additional features. Okay, so Maven is an open source tool which is being given by Apache, which is used specifically for Java-based system. Okay, where Maven internally runs on Java only. What you mean is the Maven itself is created using Java. So Maven is a Java-based tool which runs on Java and it is for Java system. Okay. So in that case, now let's try to understand how Maven works. So first of all, Maven is not just a build tool like what I was talking about Ant. Maven is actually a project management tool. So what do you mean by a project management tool? So it can take care of the complete project, where what it does is it tries to treat our project as a object model. Okay, so what do you mean by object model? It is the OOPS concept. So in the OOPS concept or the object-oriented model, that is the C++ or Java, we will be dividing the components into objects, and using the objects we'll be able to easily call any object and or we'll be able to call any functionality and will run. In the same way, what Maven does is it will split our project into objects, and using that objects, it will try to take care of the build step easily. And what else that Maven does? Maven gives us a set of standards. So if you are using Maven for doing a build of your Java system, then you will be following a set of standards. Okay, so what that standards are, we will look a little later. But remember, it follows a set of standards. And along with the standards, it gives us a defined life cycle. So when I say life cycle, now what is that we have to do first? What is that we have to do second? Then when will you do the test? So all these kind of things will be little complicated and it will not be easy for someone who begins with. That is when what Maven will do is, along with providing a standard, it will also help us by providing a defined life cycle, so that we can always go through the life cycle what Maven gives and create a product or build a product from the Java file. Okay, and finally, what it does is it takes care of a complete dependency of our project. So it works as a dependency management system. So for doing the compilation, many times there might be some dependency of the Java itself, where this Java file can contain some of the data from this Java, or this Java can contain some of the content from this Java. So like this, when you have dependency, which one should you be doing or the compilation first? So you have to do the 3 first, then 2.java, and then come to 1.java. So those kind of dependencies can be easily achieved using Maven. Okay, so remember, Maven is not just a simple build tool, but it is a superset of build tools which has various features of different build tools. So that is when, by providing a standard and giving a defined lifecycle, Maven will be able to take care of the complete project, and hence it is called as a project management tool. Okay, so if you see the advantages that we will have using Maven is, first is it is an easy step, or it will be very easy to set up the build automation for your project using Maven. And then, since we follow a standard in Maven, no matter what kind of product that you're going to use to Maven, to create a product using Maven, then everything will follow the same standard. Because of this, the build system will be uniform across all the products. And because of that, we can do a lot of reusability, and the maintenance will be very, very easy because everything is going to be similar. Suppose if you are creating another new product based on Java, and if you want to set up a build automation for that, you can reuse the existing build system for another product, and based on the same way, you can quickly set up the build system for that new product that you're setting up. Okay, so in that way, it's quite easy and it is effective way of doing the maintenance. Now, when you talk about the futures of Maven, like I said, Maven doesn't just work as a build tool, but it acts as a superset of various features in different tools. So Maven will act as a build tool to take care of the compilation and take care of creating the deliverables. It will also act as a dependency management tool where automatically when you have certain dependencies, that will take care. Let's say this is a simple diagram of your project where first you have one component and that component is dependent on some other component, and these are the same dependencies for this component, and further you can have a different level of chain where this file depends on this component or another file, and it goes on. Whereas if you use Maven, if you just give one dependency, it will track the complete dependency whatever is needed for that component or file, and it will take care of how to solve the dependencies. Okay, that is why it is also going to act as a dependency management tool. And followed by these two, it is also going to act as a documentation tool where you can create the documents for the product in terms of what is happening, what and all are the files which will get affected, what is the deliverable, what is the dependency, all those details will be documented easily. Okay, so clear so far on what is the overview of Maven? That it is a superset of various features. Okay, and remember, Maven is a Java based build tool and it runs on Java itself. Okay, so it is a Java based build tool and it uses Java to run everything. So it is a Java based tool for the Java based system, and it is also going to use Java for running everything. Now, so let's say you have a project which is being based on Java programming. Now, what is the architecture on which Maven will be working? So to understand this, first, let's say when you have a product which has all the set of files. So now, going back to the previous module. So let's say you have a project, and in that project, you are trying to work on Java file. So in that case, now on that particular repository that you're using for storing the files for that particular Java based project, now you will be having a central repository, and in that central repository you will be storing as a developer all the changes that he does. Okay, so now if he wants to do a build, basically he has to create a workspace, or he can use his existing workspace, and inside that he can do the build where you already have all the files inside it. Okay, so in that way, now consider that you have one such workspace, and inside it you have all your source code, that is the Java files specific to that project. Now, in any build system, it could be a Maven tool or an Ant or any other tool like Makefile. Ideally, what will happen is, for all the build tools, you will have a file called as build configuration file, and that file will have all the details about what to do and how to do it, what and all are the dependencies. That is, basically it will define the workflow and all the details about the project inside that configuration file. So it is mandatory that every project should have one configuration file. Okay, so that will have the definition and the details on how the project is going to be built. So in that way, for Maven, that configuration file is what we call it as a pom.xml, or generally we call it as a pom file, where the extension of the file is of the type XML. So why am I talking about this? So for every project that you're working, ideally, along with the Java files in that workspace, you will also have a pom.xml file, which will have the instructions on what to do, how to do, and the complete details about that project. So now, when you want to do the build of that product, inside which you have all the Java files, and along with this you have the pom.xml. Now what will happen is, when you invoke Maven, that is run the build tool called Maven, you will go inside this workspace where you have the pom.xml, and in that directory you will be invoking the Maven. And when you invoke the Maven, based on the instructions what you have given, it will first read the configuration file called pom.xml, and inside that, whatever details that it has given on what you have to do, then based on that, it will start working. Where, what is that you have to do? So now when you say you need to do the build, there are two things that it will do. One is, it has to perform some operation like compilation or doing a unit test or creating a package. Now, for doing all those things, you need to specify what is the file on which it has to do something. That is it a Java file on which it has to do the compilation and create class files? Or is it a class file out of which it has to create a deliverable? Or do you have to run some unit test against this class files? So like that, we will be giving the instructions, and based on what it is given in the pom.xml, it will try to run the tasks. Okay, so that way, what files is getting affected is the first thing. And the second thing is, for doing that, you will need certain libraries or something called as plugins, using which Maven will be taking care of the tasks. Okay, so the two things what Maven does when you invoke a Maven against a project file in the workspace is, first, it takes the list of all the source files on which you are going to work, and second, corresponding to the source file, whatever is the tool or the library files that you need to perform some action is what it will take. So when I say the library, it is nothing but a file which Maven will internally invoke and run some task. Let's say, for example, you are telling to the Maven, Maven, do the compilation. Maven, create a deliverable. Maven, delete a file. Something like that. If you say, for doing each of the step, it will use a library, and using that, it will be executing the steps on the files that it has to be changing. So that is when you run Maven, it will do two things. First, take a list of files which is going to be affected, and second, for running the step that you have specified, whatever deliverables or the libraries that it is needing, it will take the list of that first. So first thing what it will do is, it will take the list of it. Now, after it takes the list, it has to perform the operation, right? So to perform the operation, it will use that library against the list of files that it has generated that will be affected. So for example, if you're saying to the Maven, compile all the files in this workspace. So it will try to first take all the list of Java files that you have on which you have to do the compilation. And second thing, to do the compilation, you need a library called compiler, or if you're doing a pretty much a deliverable creation, then you will be invoking a file like jar or var. So what exactly is that library that it has to use, right? So that will also be picked, and using that library, what it will do is it will try to run the compile step and do the conversion of the list of Java files that it had. Okay, so like that it will do. So to do it now, on this workspace where you are running everything, you will have on the source code, that is the Java files. But where will we have all the libraries that the Maven will be using? So what will happen is, initially when you install Maven, what it will do is it will create one directory in the machine on which you have installed Maven, and that directory is called as local repository. And it is the repository or a directory on your machine where Maven stores all the libraries that it needs to perform a build step that you are trying or you are asking it to do. Okay, so now when you first run the Maven, and when you tell what is that you have to do, now based on the information in the pom.xml on what you have told, it will generate the list of files that is going to be impacted, and it will try to take the list of object files, or I don't call it as an object, I will call it as again as a library, which the Maven will use to run it. Okay, so for taking the libraries, it will come to the local repository, and from this it will pick up and run the step whatever it has to do. Okay, so that way, after taking the list of files and the libraries, it will go to the local repository on that machine, and from this directory it will try to take the library and execute the step against the files in your workspace. So that is what it will do every time. And when it is doing, what will happen is, not all the files or all the libraries will be present, because when you install Maven, only a certain set of libraries will be coming along with the Maven installation. So whenever you are trying to do some different task, for that task you need a specific library using which Maven will be executing the task. So in that case, that library, when it is not available on the local repository of your machine, what Maven will do is it will go to the internet, and in that there will be a repository called remote repository, which is maintained by the Apache Maven. And from that location, it will download the library and put it back to the local repository, and from there it will try to run it. So like this, whenever you are running a step for the first time in Maven, that library, when it is not available in the local repository, Maven will go to the internet, and on the remote repository, it will try to download the file back to the local repository, and then it will start using it from here. So that after this, when you invoke the same library, it will already be there in the local repository. So it will use this. So pretty much now, if you remember that in order to connect from the local repository to the remote repository, we always have to be online. So that if it is not online, then for the first time when you run something, the library will not be here. So it will not be able to download it from the net. Okay, so this is how a typical Maven works. Getting it on how it works? You will.
Yes, Adam.
Certain.
So you will have a workspace. Inside the workspace, you will have a configuration file, and that configuration file will have all the details specific to your project. Okay, and now when you run Maven, you will tell to the Maven what you want to do, and based on that information and the information in the pom.xml, it will try to take the list of files on which it has to do that action, and for doing that action, what libraries that it needs. So then it will go to the local repository, use that library and run the step. And in case if the library is not found, it will go to the remote repository and then it will try to download it and then use it from the local repository. Okay, so now if you understand it a little deeper, now when you run Maven, you will be basically invoking a library or an executable called Maven, that is MVN. So this is the executable which we will be running, just like for Git, how did we use a executable called Git? Same way, for Maven, we will call a executable MVN and we'll be running this to invoke all the steps. And when you are running this, you have to always pass an instruction on what is that you have to do. Okay, and that instructions that you will be passing is what we call it as a goal. So ideally here, when I call a Maven command or invoke the Maven executable, I will be giving it a goal that it has to do. So the goal is nothing but what exactly you want Maven to do. Okay, so based on the goal, it will go and read all the necessary files and prepare the list based on the pom.xml, which gives the configuration. Okay, so now a goals is nothing but that instructions that we are asking the Maven to run. So what the Maven wants to do, that is what we will be giving by the term called goals. And internally, when you try to achieve a goal, I was saying that it needs to use a library that it will go to the local repository and use it. If it is not there, it will download, right? So that libraries are nothing but plugins. Okay, so what is a plugin? A plugin is nothing but, once again, a simple jar file which Maven itself has. That is why I said in the beginning, Maven runs on Java. It is a Java based tool and it also internally runs on jar or Java, which means this itself is a Java based tool and it is built using Java itself. And all the plugins, whatever that you're going to use, will again be a jar file internally. Okay, so now whatever that Maven is going to use to execute the goals are called as plugins, and whatever that it downloads is also a plugin only. So now to be more specific, when you go to a project inside the workspace, if you execute Maven and pass a goal to it, then based on the goal, Maven will try to search for the specific plugin, and using this plugin, it will be doing a exact task. That is what you have to do on the goal. So this is how you will be invoking Maven and how Maven will be working. Okay, so going forward, we will be using these terms a lot. That's the reason I'm trying to specify on this. Okay, so anything that you instruct to Maven is what we call it as a goal. And when you tell to the Maven what goal you want to perform, it will take a list of what and all is needed for that. And in that, it will take a plugin list. And using a particular plugin which is available in the local repository, it will try to take care of the step or the task. And if a plugin is not available on the local repository, it will go to the remote repository and download it. Okay, so now, so the architecture is what we saw, where you will have workspace, a goal and a plugin and a local repository and remote repository. Now, what is that exactly we have to do using Maven? So, as I was explaining in the very first slide, I said Maven gives us a defined life cycle. right? So what is that life cycle that Maven will allow us to follow? So there is a defined life cycle, which is also a default life cycle, which we will always be following. And the default life cycle of a Maven has these phases or steps, where the very first step when you execute or invoke Maven is it will generate all the sources and correspondingly what are the resources that it is needed. It will generate a list. Okay, so that's the very first thing that it will do when you invoke Maven. And after that, it will take this list of resources, and against that whatever sources that it has generated, it will try to do the very first step called compilation, where the phase name is called as compile. And what it will do, it will convert all the list of files that it has generated, that is the Java files, into a class file. That is the very first step that it will do. And after it has completed the compile phase, it will go to a phase called test. And in the test, whatever class files that you have created using this compile step, it will try to run a unit test against that class file and verify whether everything is fine. Okay, so that after the test has been completed and only if everything is fine, then it will go to the next step called package, where package is the step in which we will be accumulating or we will be assembling all the class files that we created in this step and create a deliverable, that is a jar file or a var file. Okay, so depending on what is the kind of project that you're going to work, it will be exactly working on the creation of the deliverable. And once the package is done, okay, suppose in some time what will happen is you might have to run certain step called install. So what do you mean by install? Now let's take one simple example where you have two products. Okay, now both the product will have its individual workspace on which you will be creating some deliverable. Okay, now let's say you have one workspace which creates a deliverable called a.jar, and there is one more workspace which creates a deliverable called b.jar. So ideally when you create the deliverable, it will be created inside the respective workspace. All right, now if for instance if one of the project is dependent on the other project, then when you are creating the other dependent project, it will be requiring to use the output what you have created in this. That is, now if after completing the project A, that is creating the a.jar, if you want to create the b.jar, the b.jar should use a.jar so that it will be completing the b.jar. So in that case, now for the b.jar to use the a.jar, where will it search for? Because as I was talking about the build system earlier, the first thing that it does is it generates the list of required resources, which could be a dependent file or a plugin. So in that way, now for the project B to execute, now it needs a.jar, right? So in that case, where will it check for all the required resources, that is the plugin or these kind of files? It will go to the local repository itself by default and check whether the file is available. And now, will the a.jar be available in the local repository? No. So what will happen? The Maven will go to the internet on the remote repository and try to download the file. But will the a.jar be available on the internet? No, because a.jar is a specific file for our company or for our project, and it is available only in this directory, right? So in that case, when a resource is not available on either the local repository or the remote repository, then the Maven will fail. So that step where whatever the dependency file that we have in our workspace, that if we have to copy to the local repository, then we use the step called install. So install is nothing but copying a deliverable to the local repository so that if any other project depends on this, it can easily come to the local repository and pick it up. Okay, so that now after you do the package of project A, you do a install of project A. So as soon as you do an install of project A, what will happen? The a.jar will be available in the local repository. And now when you're compiling or when you're trying to do the build of project B, it will be having a list saying you need a dependency of a.jar. So it will take that list and it will go to the local repository, and it will check whether it is there or not. So in that case, now when it is there, it will pick it up and it will proceed with the build of that b.jar. Okay, so that step where you will copy the deliverable from a project workspace to the local repository is what we call it as install. Okay, now just remember what I said, because we will be doing all those things practically a little later, but pretty much we will be working on these things a lot. Okay, so that is what is the install step. And after the install step, you have something called as deploy. So deploy is nothing but a step where now you have created the class files, you have unit tested, you have also created a deliverable out of it. And now if you want the same thing to be put into the production system, you can run this step. So deploy means instead of copying your package to the local repository, you put it into the production system, and that step is what we call it as a deploy. Okay, so the life cycle always begins from here and it moves on one after the other. And now whenever you invoke any step, so we are free to pick up any particular step that we want in the default lifecycle from here to here. But when you pick up a particular step to run, what Maven will do is Maven will always come from the beginning and then stop at that place where you have asked Maven to invoke. So for example, if you tell to Maven, you do the packaging, then what it will do is it will come from the beginning always. So it will first generate the sources and resources, compile it, test and verify, and then create the package. Suppose if you say test, then it will come from the generating source, compile it, and then test it. So like this, on a default lifecycle, it will always come from the beginning, because without generating the source and resource, you cannot do a compile. Without doing a compile, you cannot do a test. And without doing a test, you cannot create a package. That is why it comes as a dependencies of step one by one from the beginning. Suppose if you say install, it will always come from the beginning, go to compile, test, package, and then to install. Okay? Now, in the other way, if you look, when I was talking about goals, what are these goals? So a goal can be something which we are using with the reference of what we have given in the pom.xml, or whatever that you see here, right? These are also default goals of Maven. So now when you are invoking Maven, this is what you will invoke. So when you call a Maven, you will be calling it like this. So you will call it as Maven and a goal name. So now based on the goal what you have called, it will go through the life cycle. If you say Maven compile, what it will do, it will try to come to this step. And if you say Maven package, then it will come from this step and this step and this stop here. So like that, these are the goals which we will be passing it, but internally it is also a life cycle where it will come from the steps from the beginning. Okay, so these are the default life cycle phases. But in addition to this, we also have two more life cycle phases. Okay, that is called as clean and site. But these are not part of default, which means if you now call this any of this goal, it will not call all these things from the beginning, and it will execute only that goal. It won't do anything else. That is why it is not part of the default lifecycle. Okay, so in that way, what does clean do? So when you say Maven clean, it will try to delete all the runtime files that you have created in your project. So when I say a runtime file, it will delete all the class files that you have created, and for running the unit test, whatever the output files that you have created or the log file that you have created. And when you did the package, you would have created a jar file or a var file, so that will be deleted. So that way your workspace will be clean of all the runtime files. So it will not delete everything, it will delete only the runtime files. Okay, and site is a goal using which we will create a a documentation. So we'll talk about these little later again. Okay, so now remember, these are the default lifecycle goals and these are the non-default, which means if you invoke any one of them, it will come from the beginning and stop at that place. But if you call any of these two, it will do only that and it will not do anything else. Okay, so as an example, now if you say Maven install, what it will do, it will first invoke the generation of sources and resources, then do the compile, and then do a test, and then package, and after the package it will do the install. But if you do a Maven clean, it will do only the clean. Suppose if you are passing multiple goals, that is Maven clean and compile, then first it will do the clean and after that it will do compile. And for the compile step, we know it will first begin with the invoking the list of sources and resources and then come to compile. Okay, but what will happen if you do sometimes together, like compile and install? So when you have to do compile first, it will generate the list and it will do the compile. And for install, once again it has to do from the generating step and compiling and testing, right? But if you see here, it will not repeat the steps because Maven is smart enough to understand just before running install, you did the compilation step. So that is why when you are calling install after that, then whatever is left from compile, that is the test and the packaging, it will proceed and then do the install. Okay, this is how Maven will be invoking the steps where we will be passing the goals, which is nothing but the lifecycle phase of the Maven. Getting it?
Yes, Adam.
Yes, Adam.
Yeah, I understand that.
Okay, so now in the definition of Maven, I said Maven gives us a standard and Maven gives us a life cycle. So we saw what is the life cycle, but what is the standard that Maven gives us? Because if you remember, I said no matter what kind of project that you're going to use, if you're using Maven, you will always follow a standard, right? So what is that standard? So the standard what we are going to follow in Maven is a directory structure. What do you mean by that? Which means now, if you are having a project which is going to have Java files in it and you are using Maven to build it, then you cannot put all the files randomly and you have to put it exactly in a directory structure which Maven will understand. And because of that, it will be very easy for us to do the build step. Okay, and we have to follow this standard for all the projects which we are going to use to build using Maven. So in that case, what is the structure that we are going to find? So the very first thing that we will have is, when you go to a workspace, inside the workspace, first you will be having a directory called src. Okay, so everything will be inside it. So now when you go to a directory or a project, inside that you will be having a folder called src, and under src you will be further having two folders called main and test. Okay, and now inside this main and test, further we will have certain files. But first let's understand, why do we need main and why do we need test? Now any files that you are going to put it, which will be part of the project, will be inside src. So the directory structure of your Maven project begins with src. This should be the very first folder that you will have inside the workspace, and inside that you will be having a main project, that is the main directory. And main is the directory which will have all the files which is going to be acting as your project files. Okay, so whatever the actual Java file that you will be writing, that will be considered for the compilation, and it will be taken to create a jar file or a var as a deliverable, is what you will be putting it here. Okay, and test is a folder which will contain all the testing related files, which is going to test each and every file that you have inside the main folder. Okay, so this is going to contain the actual source code for the project, and this will contain all the files using which you will be testing each and every file that you have in this main folder. Okay, and further if you see, you will be having many other folders inside main. So what and all are they? Now the first thing what you will have inside a main is a folder called Java, and things like Java, where this is what will be containing all the actual Java files that you're going to write. So all these things, whatever that I was saying initially, right? Rather than putting it randomly, you will put everything under the Java folder. Okay. Now, in addition to this, you might also have a folder called resources. Suppose if there is any dependency for the Java files or a library which we need to use for the compilation within the project, then you will have one more folder called resources, and that will be inside the src main, and you will store everything here. Okay, and further, let's say that your project that you are working is a web-based project, then you will be having a folder called web app and config, where specific to your web application details or whatever the configuration files like the XML files that you need to specify your web application will be put here. So like this, you will have certain other folders depending on the project what you will be having, and everything will be inside the src main only. Okay. Now, when you take a Java project, for doing a test, you have to write some file, and that will again be a Java file. Okay, so that is when inside the src test, you will also have a Java file folder, and that will contain all the files using which we will be testing each and every file that you have here. So for example, if you have a file called one.java, then inside the src test Java, you will have one test.java, something like this, where this file will be used to test this file. Okay, so like that, all the unit test files which we will use to test this will be present under the src test Java folder. And further, for supporting this test, if you need any resources or libraries, you will be putting it inside the src test resources folder. Okay, so like that you will be having further subfolders within the src test. So majorly the structure is you should have a src folder, and inside that you will have two further folders called main and test, where the main will contain all the actual files that will be treated as your project files, whereas the src test will have all the test related files using which we will be testing those files under the src main. And further, inside the src main and src test, you will be having folders like Java resources, which specifically will contain the files based on the type of the folder. So Java will have all the Java files for src main. The Java folder here will contain all the test related files. Okay, so this is the structure that we have to follow when we are going through a Maven project. And the other thing is the pom.xml. So when you open a workspace in Maven now, you will be seeing two things. First thing is a directory called src, and then you will see the pom.xml. So this is the standard that we have to follow, where have a directory structure called src, and inside this follow this format. And next, the pom.file or the configuration file that I was saying should be present in the same directory level as that of the src. Okay, so this is the directory structure that we have to follow. So as we go through the classes, we will see that this is the structure that we will follow, and we will be following the defined lifecycle phases one by one. Getting it?